All right, example 5. Here's the thing with example number 5. This is kind of one of the main things we do with our trig functions, is you're going to be given a trig expression. Notice it doesn't have an equal sign, so it's just an expression and needs simplified. So we are supposed to somehow simplify this. So let's see what we're looking at. Sine t plus cosine, or cotangent t, cosine t. I know it's weird that they use t's, but the book I was looking at had t's, so I use t's. You could change them to x's if you wanted to. So this could easily be, if you wanted, sine x plus cotangent x, cosine x. I don't have a problem with that, as long as you keep it really nice and organized. And then if there's not a problem that involves any other letters, it shouldn't be a problem at all. Your first line of defense, when it comes to, you have a sine here, and you have a cotangent here, and you have a cosine here. Your first line of defense, if you don't know what to do, is look at any trig function out of the ones you're looking at, and any of them that are not sine or cosine, take note of. This right here is not sine or cosine. Any function that's not sine or cosine can be turned into sine or cosine using this. Like one of these top sections, either the reciprocal identities or the quotient identity. So what we have is cotangent x. So what I'm going to look is for some cotangent x in these first identities. I see it right here, cotangent x. I could turn it into 1 over tangent. That still doesn't help me make sines and cosines. So when I look at this one, cotangent x can be turned into cosine over sine. That's what I want to do. So your first line of defense is anything that's not sine or cosine, turn it into sine or cosine. Figure out how. So we're going to make a change, and the identities are going to let me change this piece. So I have sine x plus, be careful, cotangent said I can change that into cosine over sine. And this is going to become cosine x over sine x. And then there's this cosine x right there. Remember, these are being multiplied. All right, so that's what we're going to do. The next thing is when you got cosine x over sine x times cosine x, anything that's hanging out to the right of the fraction can be multiplied into the numerator. So we won't have to have that cosine hanging out. We're going to have sine x plus, it's going to become cosine squared x over sine x, like that. Unfortunately, this gets simpler, or more simple. I'm not sure which one it is. But we're gonna have to keep working. So here's the thought. You have two things that you're wanting to add. One of them's a fraction and one of them's not. So make it a fraction. And then going back to like just the general rules of math and fractions, if you wanted to ever add two fractions together, they have to have the same bottom. Just like basic middle school level math here. Say I had 3/5 plus 4/5. Well, that I can add up together and get 7/5. And that is good. But if I had, say, 3/5 plus 4/7, I can't add that up and make it to be like 7/12. That is bad. You have to get the bottoms the same. So what I'd have to do is I'd have to multiply this one by 7 over 7. And this one by 5 over 5. So then I'd get 21 over 35. And then over here I'd get plus 20 over 35. And it looks like I'd end up with 41 over 35. That's how you have to do your fractions. And that's good. We're going to have to do the same stuff with the trig. And the one that wasn't a fraction, you just put over 1. So to get these down to the same bottoms, you take this bottom right here, and you put it here and here, sine x, kind of put it there at a little slant and of an angle, so you know. And I don't usually do this. You take this one, if this one's a 1, you put 1 and 1 here. You don't really have to do that. You can, but no need to worry about multiplying by 1 over 1. All right, so multiply this and this, so this becomes sine squared x over sine x. Then my plus sign. And then you got cosine squared x over sine x. Now that they have the same bottom, you've got these two pieces, these two fractions with the same bottom. Now you can combine the fraction together and make like one fraction. So it would just be sine squared x plus cosine squared x over sine x. Just like when I had if I had 2/5 and 6/5, I'd put together and make 8/5. The bottom is still a 5. So sine on bottom, still sine on bottom. I know you'd love to be done at this point, but you're not. This, the better you get at this, the more you realize that's special. Sine squared x plus cosine squared x. I've already got it circled on this thing. Anytime you see sine squared x plus cosine squared x, you take it and you turn it into a 1. Sine squared x plus cosine squared x always makes a 1. So what we have here actually turns into, instead of sine squared x plus cosine squared x over sine x, it just turns into 1. This thing right here turns into 1. So it turns into 1 over sine x. And that's pretty good. You could be done here, but that's on this little sheet of paper as well, and you got to find it up in the top. 1 over sine x. I'm looking for it. No. Oh, here. 1 over sine x or 1 over sine u would turn into CSC or cosecant. It's using the reciprocal identities right here. If you ever have a 1 over sine, you can turn it into a cosecant. So this thing, this turned into 1 over sine x, the simplest it'll actually get, all that work, so it can turn into a CSCX. And that's it. That's as simple as it gets. We started out right here. We started out with this, and remember we were using t's at the beginning. And then we pulled the sine out, or no wait, we started out by changing the cotangent into cosine over sine, multiplied your cosines in and made it cosine squared over sine. Then what we did is made this a fraction with a 1 on bottom, and then we had to get the fractions to have the same bottom, so we multiplied by sine over sine. And that made this one sine squared over sine and cosine squared over sine. Once they have the same bottoms, you can like add them together and give us this. That top is the thing that turns into 1 that you always have to look out for. So this became 1 over sine x, and then that just turns into, using identities, using this,